Hey y'all, Data Guy here, and today I want to talk to you about a problem that's arisen over the last couple of years around LLM hallucinations and also how to fix it. So, if you've ever never run into it, imagine this scenario where you ask an LLM a question about a table schema it's never actually seen, and it won't hesitate, it won't hedge, it'll just tell you the primary key is customer UUID, very confident, very specific, and formatted like an answer that came from documentation, but it completely made it up and that column doesn't actually exist. And it's worse than a normal error because if this query threw a stack trace, you'd stop, read it, and fix it, and errors would announce themselves. But a hallucination won't. It'll look exactly like a correct answer, grammatically clean, confidently phrased, and structurally identical to a real answer, and nothing in the output flags, hey, I'm wrong. And if you're then piping that into a script, report, dashboard, or a chatbot, it'll go downstream looking as exactly as trustworthy as everything else. So that's the core problem I want to dig in today. Not AI sometimes gets things wrong because every system does that, but rather the problem that hallucination is a structural property of how these models work and how you can plan for it and fix it, because it's not just a bug sitting in some corner waiting to be patched. It's always going to happen and there's ways you plan to avoid it. So once you understand why it happens, the fixes will make a lot of sense and they're real concrete ones. And that's what we're going to go through today. Why LLMs hallucinate and the specific techniques that'll measurably cut it down for your use cases. So first, let's kind of go in and understand why this happens. So the mental shift that matters more than anything else in this video is that an LLM is not a database. It doesn't look something up and return it. And at inference time, it's doing one thing over and over again, given the text so far, predict the most probable next token. Whole mechanism. So there's no lookup step, there's no check if this is true step or built-in fact table it's querying against by default. It just learns statistical patterns across a massive training set, and at generation time it's sampling from a probability distribution over what word is likely to come up next given everything before it. And most of the time, probable and true line up pretty well, right? Because the training data most reflects reality. If you ask what year World War II ended, 1945 is both the most statistically likely continuation and the correct one because millions of documents reinforce that exact pattern. But the model has no separate mechanism for verifying truth. It's optimizing for plausibility, a text that reads like a good answer, not for factual accuracy. So if you ask it something narrow or unrepresented in training data, something about your specific internal system that it was never trained on, it'll just generate the most plausible sounding continuation it can and doesn't have a way to say, I have no signal here unless something explicitly steers it there. So it fills the gap with something fluent and specific sounding because fluent and specific is what answer-shaped text looks like. And that's the root cause. It's not that the model is lying or broken. It's doing exactly what it was trained to do, which is produce the next plausible token in a situation where plausible and true have quietly separated and no longer mean the same thing. So where does this problem typically kind of rear its head and bite you in, data work, right? Because it's not just an abstract AI safety problem. So if you work with data or build on top of these models, it'll probably show up. And within data, it's particularly damaging, right? First, invented schema, right? If you ask an LLM to write a query against your database, it'll sometimes invent column names or table names or create entire fields that sound exactly like something your team would have named, which is very, they'll make names like created at utc.isActiveFlag, which is very plausible, but, not real. Then, second, you might have it generate SQL that's syntactically correct but semantically wrong. It'll generate a query that runs with no errors and returned results, but joins in the wrong key or silently drops rows to the wrong filter logic and nothing crashes, but the output will quietly lie. Third, and it's kind of a sneaky one if you're building with RAG and your retrieval augmented generation, is fabricated citations. If you ask a RAG system to summarize a source and cite where it got each claim and hands you a page number or a document title that looks completely legitimate but doesn't correspond to anything in your actual source set, it's not quoting your documents, it's generating text shaped like a citation. And I've also seen teams ship reports where the query will run cleanly and the numbers look reasonable, but nobody checked the join. And the common thread across all three problems is that nothing about the output signifies verify this. It's the same fluency, same confidence, whether the answer is grounded in something real or if it's made up on the spot. And that's the part that makes this a pipeline risk instead of just an annoyance. So now that you know about the problem, how do you actually solve it? So first, if the root cause is the model is filling gaps with plausible guesses, the most direct fix is just stop leaving gaps. Give it actual facts at the moment it generates the answer so it has something real to work with instead of falling back onto its training data instincts. and that's the core idea behind RAG, right? If you watch my video on RAG and chunking, this is why that architecture matters here. Instead of asking the model what's the primary key in the customer's table, you say you retrieve the actual schema documentation, chunk it properly, pull the relevant piece, and hand that to a model as context. And now it's not predicting from a vague statistical impression of what tables it usually look like. It's reading the real answer and then reformatting it for you. And this is why chunking quality will matter so much for hallucination specifically, not just for search relevance, because if your retrieval step pulls back irrelevant or poorly split context, the model still doesn't have real grounding. It's back to guessing, but with more noise added to the prompt. Good retrieval is hallucination prevention. So, think about that because it's how you prioritize your RAG work. RAG doesn't eliminate hallucination entirely. The model can still misread or misstate what's sitting right there in the retrieved context, but it'll turn an unconstrained guess problem into a much smaller reading comprehension problem, which means a huge drop in error rate, and it's the single highest leverage fix on this list. Then we have a couple other techniques you can use. And typically, when you're using these, you might want to stack them. But the first and second technique is the simplest one to implement, which is temperature. Temperature can control how much randomness gets injected into that token selection process I described earlier. And a higher temperature means the model will readily pick lower probability, more creative continuations. Low temperature pushes it towards the single most probable next token every time. So for creative writing, higher temperature is often what you want. For a data pipeline generating SQL or extracting structured fields or answering factual questions, you want temperature near zero. And it won't fix a genuine knowledge gap, but it removes an entire category of unforced hallucination, the model wandering off into a creative but false answer when the boring, accurate one was right there in the distribution. Third, change what you're asking for in the prompt itself. Explicitly instruct the model to cite where each claim comes from, and importantly, explicitly give it permission to say it doesn't know rather than guessing. And this sounds simple, but it works because of the mechanisms from Chapter 2. The model is trained to produce plausible sounding completions, and by default, a filled-in answer looks more complete and rewarded than an admission of uncertainty. So if you never ask for citations or explicitly allow I don't know as a valid output, you're implicitly pushing it toward filling every gap. So ask for sourcing and make refusal an acceptable answer, and you'll shift what a plausible shaped output looks like. And then fourth, something you should also treat as non-negotiable, don't trust the output, always verify it in code. If the model generates SQL, run it against a schema validator before execution, or actually execute it against a read replica and check the results before they hit anything downstream. If it generates a citation, programmatically check that page or quote actually exists in the source document. If it produces structured data, validate it against a schema. The model doesn't know when it's wrong. Your validation layer can catch it even when the model can't. And none of these four techniques is a complete fix on its own, right? You want to stack them together, as I talked about, and they'll compound, and that's how you get a system that hallucinates rarely enough to actually trust within production. Now, even with all of those techniques in place, some things are occasionally going to slip through, and that's why production LLMs need an evaluation layer, a systematic way of testing outputs against known correct answers and tracking hallucination rate over time and catching regressions before they ship to users. And that's a big enough topic of its own, so I'll save that for another video. But bringing this video together, hallucination happens because LLMs predict plausible next tokens, not because they retrieve verified facts. And when two diverge, plausible wins by default, and this will show up in data work as invented schema, silently wrong SQL, and fabricated citations, all delivered with the same fluent confidence as a correct answer. And you can reduce this by giving the model real facts through RAG, lowering temperature for factual tasks, explicitly asking for citations or permission to say I don't know, and validating everything programmatically before it goes downstream. But obviously you can't fully patch this away, but treating it as a known failure mode you engineer around is the same way you'd handle under any other unreliable component in a pipeline. Helps it to stop being dangerous and helps you plan for it for the long term. So that's everything I had for you for this video. Just wanted to make a quick video on this topic because I see it so often, and it's a relatively easy fix. It just requires some process hygiene. So I hope you enjoyed this video. I hope you learned something from it, and I hope you have a great rest of your day. Data Guy out.